Have you ever really looked at a piece of sheet music? I mean, on the surface, it's just a bunch of lines and dots, right? But what if I told you that it's not just a language for musicians? What if it's also a map, a mathematical graph, and even a kind of scientific formula, all rolled into one? Today, we're going to decode these hidden connections. We're going to see how a simple musical score is actually a key to understanding so much more about the world. Let's dive in.
All right, so let's start with a classic question, one that people have been debating for, well, forever. Is music language, or is it math? Is it all about feeling and pure emotion? Or is it just a rigid system of patterns and frequencies, cold hard numbers? It's a huge question, and the answer, well, it might not be what you think.
The thing is, it's a bit of a trick question. It's not either or. It's definitely both. But, and this is the really cool part, the story doesn't stop there. Because it turns out that music also shares its DNA with things like geography and science. It's woven into this massive network of human knowledge. And once you see these connections, you will never look at music the same way again.
Okay, so where do we even begin? Let's start with the absolute most fundamental piece, the staff. You've seen it a million times, I'm sure, but for the next few minutes, I want you to see it in a completely new light. Don't think of it as lines for music, think of it as a graph for sound.
This is our canvas, just 5 simple lines and the 4 spaces in between. The whole system is designed to do one really elegant thing, to visualize sound, to turn something we hear into something we can see. The rule is incredibly simple. The higher a note is placed on the staff, the higher its pitch. It's a brilliantly intuitive way to literally graph a sound wave.
And here's where we hit our first aha moment. This system probably looks a little familiar, especially if you remember your old math classes. It is almost identical to a Cartesian coordinate plane, with x and y axes. Both of them use a grid where vertical position represents value. On a graph, that value is a number. In music, it's a pitch. But here's the crucial part. Both of them are completely useless without context. A graph is just a grid until you label the axes, and a musical staff is just 5 lines until you add a clef. So if the staff is our map of sound, how in the world do we read it? That's where the clef comes in. I want you to think of it as the legend on a map. That little box in the corner that tells you what all the symbols mean? Without it, you're just looking at squiggles. You're totally lost.
So what is a clef, really? It's just a single symbol at the very beginning of the staff that anchors everything. Its entire job is to assign one specific note to one specific line. And from that single anchor point, every other line and space suddenly has an identity. Now, let's look at the two you'll see pretty much everywhere.
First up is the treble clef, which you might also know as the G clef. And the reason for that name is hiding in plain sight. Take a look at how the main curl of the symbol wraps perfectly around the second line from the bottom. That's its entire purpose. It's a visual cue basically pointing and saying, hey you, this line right here, this is the note G. And from that one single reference point, we can figure out all the other notes. Now for the lower pitched instruments, we use the bass clef, or, you guessed it, the F clef. And again, the clue is baked right into the design. See those 2 dots? They hug the 4th line from the bottom, basically putting it in a bullseye. They're marking that line as the note F. It's another piece of brilliant, simple design that anchors the whole musical landscape.
And this quote just gets right to the heart of it. A clef is more than a symbol. It is a key to deciphering musical notation. It's not just a fancy doodle they put at the start of the music for decoration. It is literally the master key that unlocks the whole thing.
And this brings us to our second huge connection, geography. Just think about it. A map is totally useless without its legend, and a staff is totally meaningless without its clef. The staff is the terrain, the notes are the locations, like cities and rivers, and the clef, that's the legend that tells you what it all means. Trying to read music in the wrong clef, that's exactly like trying to find your way through New York City using a map of London. It's not going to work.
Okay, so we've got our map and we've got our legend. But what happens when the music goes off the map? When the notes get so high or so low that they don't even fit on the 5 lines. Well, it turns out music has a beautifully simple solution for that too. I mean, instruments and voices have enormous ranges, right? Way beyond what can fit on just those 5 little lines. So how do we write those notes down? How does the system expand to handle them?
The answer is ledger lines.
And they're really just short, temporary lines that you add above or below the staff whenever you need them. They act like these on-demand extensions of the grid. It's such an elegant way to expand the system infinitely without ever having to change the basic rules.
And this leads us to our next really surprising connection, science. Think about how scientists write gigantic numbers. They don't write out a million zeros, do they? No, they use scientific notation. Well, ledger lines do the exact same job for music. They are both these brilliant little hacks designed to handle extreme values while keeping everything clear, concise, and readable.
So what about the names of the notes themselves? You might expect some complex, convoluted system, but it's actually incredibly simple. Music uses this tiny little vocabulary, just 7 letters from our own alphabet, A through G. That's it. Once you get to G, the whole pattern just repeats, starting over at A, only at a higher pitch.
And that reveals our final huge connection, language. The English alphabet has just 26 letters, but from those few symbols, we can create an infinite number of words, stories, poems, everything. Music works on the exact same principle, but it's somehow even more efficient. With just 7 note names, it builds a totally limitless universe of melodies. Both systems are these incredible engines of creation, using a small, finite set of symbols to build something infinite.
So, wow. We've connected music to math, geography, science, and language. Let's try and bring this all back together and see how we can actually put these ideas into practice.
Let's just recap real quick. The staff is our mathematical grid. The clef is our geographical legend. Ledger lines are basically scientific notation for extreme pitches, and the note names, that's our alphabet. Each and every core concept in music shares a fundamental principle with another field of human knowledge.
And honestly, the best way to really understand these connections is to just experiment with them yourself. Try plotting a simple melody on a graph and see its mathematical shape. Or try to decode a mystery clef like it's a map legend. When you start playing with these ideas, you really see just how deep these connections go.
So, what does this all really mean in the end? It means that music theory isn't some dry, isolated set of rules that you have to memorize. It's actually part of a much bigger, much more interesting human story about how we create systems to organize our world, to communicate complex ideas, and ultimately, to find meaning.
So I'll leave you with the challenge. Now that you know how to look for them, you're going to start seeing these kinds of patterns everywhere, I promise. Think about the other languages in your world, from the computer code that runs your phone to the chemical formulas in a science class. Where else can you find these hidden rules of structure, of symbols, of context? The connections are out there, just waiting for you to find them.